by using these slides and all. Okay, by using these concepts, now we will design our wing, like a swept wing or blended wing, and other wings, like different wings what we have seen so far in our theoretical class. Okay, so those kind of wing will design by placing or by adding like this kind of aerofoils. Okay, so what we'll do, we'll open our open VSP software. We'll go to our open VSP software. So here is our software which I already designed. I'll delete this. Yeah, I will add one default wing. I'll select wing and I will add. Okay, we got the default wing. Okay, and I will check the aerofoil. The default aerofoil what we have, that is the 4 series aerofoil with thickness to chord ratio 10% and 0 camber, and location of camber is 20% from the leading edge. That is the default aerofoil. Okay, so here the chord, this is the mean geometrical chord for the wing. Here what we have now, this chord, this chord, this one, see. So this chord is the mean geometrical chord of the wing. Okay, as I move chord, then observe that root and tip chord also changing, right? As I move this mean geometrical chord of this wing, okay, then we can observe that the root and tip chord also changing. So here this is our root and the tip, right? And also the area and aspect ratio, that is also changing. Okay, you can observe the area and aspect ratio, that is also changing, right? The parameter, the aspect ratio and the area. So here, as we know that the aspect ratio, that is AR, generally we will write like this: aspect ratio AR equals to B square, square times of wing span divided by the area. Yes. Okay, so here suppose you have designed a rectangular wing or some sweep kind of wing, like this what we have. Okay, so in this case we know this is our overall span, that is a projected span B, and similarly for rectangular, this is our overall projected span. From top view we will see, then that is the view, right? B span, and this one is complete wing area, right? Yes, complete wing area. So here the aspect ratio and your area, yes, these two parameter what we have, the aspect ratio and the area, that is directly proportional to your square terms of the span. So that's why if I disturb to the span, then this both parameter will change, right? So if I disturb the span, then you can observe the aspect ratio and your area that is changing. Okay, and here your aspect ratio is directly proportional to your wingspan, and aspect ratio that is inversely proportional to your wing area. These parameters you have to remember, because whichever aerofoil you select, okay, so the alterations what we'll do with respect to the aerofoil, that is the chord, okay, this chord, okay, if I change the chord length, okay, if I increase the chord length like this, then area also increasing and aspect ratio that is decreasing. Okay, area is increasing, this area, and aspect ratio is decreasing. If I decrease the chord, then the area is decreasing and aspect ratio is increasing. Okay, which means as increasing the chord length, okay, area of the wing is increasing and aspect ratio is decreasing. Okay, as decreasing chord, the area is decreasing and aspect ratio is increasing. Okay, now similarly here I'll maintain the chord length of this wing, that is 2.83504 meter. Okay, and now I will increase the span. So here if I increase the span, then the wing area and aspect ratio both is changing and it is increasing, because the chord length has to be maintained, right? It's a fixed. So here as increase in the span d, wing area and aspect ratio that will increase. Okay, so now currently we have this aerofoil, whichever aerofoil you select, okay, the parameter what we have that will remain same, which means this parameter, okay, that aspect ratio, span, and wing area. Now what we'll do, we will change the aerofoil. Okay, now suppose what I will do, instead of the default aerofoil, oh, sorry. So here we have default aerofoil, that is Naka 0010. Okay, and I will show that aerofoil. This aerofoil has been added. That is the default aerofoil. That is Naka 0010. Now I'll change the aerofoil from top to bottom, whatever we have here, just to show pointed aerofoil. Okay. So just we can able to see only point, because we have added or we have chosen the type of aerofoil, that is the pointed aerofoil. If you select the circular aerofoil, then you can able to see the view, okay, preview of the circular aerofoil, and overall wing it will look like this. If you shade, then your wing structure will be like this, the model. Okay, the preview. And if I add ellipse based, then preview, you can able to see, and you can change the height like this. You can increase, you can decrease your ellipse height. Okay, and next we have the super ellipse. In this case you'll get extra parameters, that is height and your maximum width location. Like this you can change your width location. I'll convert this shaded into wireframe so that you can easily see. So like this changes you can do as per your requirement for your wing design. Okay, Next we have rounded rectangular or rounded rectangle aerofoil. So aerofoil, if you select or if you choose your rounded rectangular type aerofoil, then you can able to see the preview. Okay, and also your wing model will change. It's like a box type of wing, right? So similarly, you can add different aerofoil, which means you can design your wing as per your required fuselage. Okay, whichever type you need, that type you select. Okay, and you change your parameters. Now here 4 series I have selected. Okay, I have chosen the 4 series aerofoil. Okay, and the default 4 series aerofoil, we have the default NACA 0088, that is thickness to chord ratio of 87% and camber 0, location of camber 20%. So for this we can do alterations like this, or if you know any number, you just type that parameters, that is thickness to chord ratio, camber and location of camber, and you can able to see the preview. Okay, and change this camber 0.15, enter 40%. I will keep, and yeah, so this is the preview. Thickness to chord ratio will change 40% to 0. Yes, see. Click in aerofoil. So number name also changed, right? Naga 9402. Similar like this, we have 6 series aerofoil. Okay. So for the 6 series, as I yesterday discussed, okay, for 6 series, we have first digit. Okay, that will indicate the series design designation, and second digit that indicates the location of minimum pressure in tenth of chord, and third digit specifies the design lift coefficient in tenth, and last two digit what we have, that provides the maximum thickness of aerofoil in percentage of chord. Okay, so here I have selected or chosen the 6 series aerofoil, and with respect to that, the default value we got. So this default value you can change as per your requirement. Okay, and you can increase your thickness to chord ratio if you want to increase. You can able to see as you increase your thickness to chord ratio. Sorry, yeah. So in this preview, you can able to see the changes, and simultaneously in this wing, I'll just change the surface. Okay, and ideal lift coefficient also you can change. So like this, we have biconcave lens. Okay, which means for this kind of aerofoils, biconcave supersonic circular arc aerofoil. You can increase thickness to chord ratio of that aerofoil, or you can decrease. Even you can select the best aerofoil. Okay, see here wing shape also got changed, and even you can increase the thickness to chord ratio, and you can change the location of that wedge. Okay, in percentage from leading edge. Okay, see 53% that wedge that is located from leading edge to 50%, 53%. Okay, from leading edge, the wedge, you can able to see the location of that wedge from leading edge, that is 53%. Okay, or you can even increase from 53% to 60%, or just you can maintain 20% or 30% like this. So here you can able to see this here, yeah, double waist aerofoil. For supersonic flight we will use such aerofoils. So in this wing also that is changing, right? You can able to see shape got changed as you change your parameter. Okay, and similarly you can add different aerofoils. Okay, is that aerofoil, CST aerofoil, Carmen, Trapeze, 4 digit model, 5 digit. So like this, we have different aerofoils as per your requirement. You can add your aerofoil. Okay, if not, okay, if you want any standard aerofoil like Boeing 737, okay, that's also available. So to do that, what we have to do? Okay, we have to go to file. Okay, let me first make it. Let me fit this on screen. Yeah, okay. So here you can add the Boeing related aerofoils. Okay, Boeing 737, the default aerofoil we have in this open VSP. Okay, script as is in this script format we have that aerofoil. So to add that aerofoil, we have to come to aerofoil menu. Okay, and just select the type, which means choose AF file, aerofoil file. Okay, and read that file. Okay, and go to favorites. In this, come to fourth option, that is VSP path. Okay, yeah, so as soon as you click on the VSP path, you can able to see the aerofoil file. Just open this and choose your aerofoil, like some standard aerofoil we have, that is 23015. Okay, LCAR 10 AVL. Okay, NACA 0012, which means 12% thickness aerofoil. So like this, we have different aircrafts. Boeing 737A. Just 2 minutes. Okay, I'll continue. Yeah. So what I was telling. Okay. So here we have different aerofoils, like some standard aerofoils. Okay. If you want to add this kind of standard aerofoils for your wing design, then you can add. Okay, here see Boeing 737A, Boeing 737B, Boeing 737C, Boeing 737D. Okay, so here A in the sense that aerofoil has been used near the root side. Okay, and Boeing 737B, this aerofoil has been used outboard section, wings outboard section side. Okay, and Boeing 737C, this one has been used complete wings mid section. Okay, and the last one what we have, Boeing 737D, that has been used near the tip side. Okay, which means here suppose you have the wing. Okay, so we have, just let me delete this. Okay, yeah, so I'll uh, split this one section into four Okay, so I'll just split this. Okay, currently I have only one section. Okay, so I'll split into four. The wing section I will split one section into four sections. That is the second section, third section, and here I will split one more section, the fourth section. Okay, so currently I have how many sections? One section, second section, third section, and the fourth section. Okay, so in this all four section, okay, this one, okay, this one is the root, okay, and this one is the outboard section, and this one what we have, this one, that is the mid span section, and the last one what we have, this one, the tip section. Okay, suppose you have designed Boeing 737 wing as per Boeing 737 wing parameter. Okay, so by using that parameter if you have designed, then for that case Boeing company they have used the aerofoil. That aerofoil is given here. Okay, Boeing 737A, Boeing 737B, Boeing 737C, Boeing 737D. Okay, A airfoil has been used near the root side. Okay, and Boeing 737B has been used outboard section side, and Boeing 737C airfoil has been used mid section side, and Boeing 737D has been used near the tip side, this side. Okay, so like this you can change your aerofoil. Okay, so currently we have aerofoil that is NACA 0010 aerofoil. So I'll change this aerofoil. So to do changes, what we have to do, just we have to click on aerofoil file and a read file, go to favorite, VSP path, select VSP path, click on the aerofoil and select your aerofoil and accept. See, near the root side that aerofoil has been added. Okay, similarly you can jump to the output section side. Let me open once again. Let me split these parts. Yeah, so like this you can add Boeing related aerofoils. Okay, at section 1, section 2, section 3, and section 4. Okay, so I'll select D. I'll accept. So that aerofoil has been added. Okay, see the name of aerofoil, Boeing 77 D aerofoil. If you want everywhere that each and every section, if you want the same aerofoil, then just come to that section. Okay, and change your aerofoil. Now that currently we have the default aerofoil here. Okay, so just repeat the same thing, like go to aerofoil file, and after this read your file, go to favorite, VSP path, aerofoil. Okay, so I'll just add the same aerofoil. Okay, that's Boeing 37AA itself. So like this you can add a similar aerofoil or the different aerofoils. Like this you can change your section 2 aerofoil, section 3 aerofoil, and section 4 aerofoil. Okay, so once you added the aerofoil, then you can do other alterations. Okay, so currently the wing what we have, that is a short wing. Okay, so the angle you can change. So angle we have, that is sweep angle 30-degree we have. So I'll just type 0 because I just want to convert this swept wing into a rectangular wing. Okay, so I have selected section 1, that's why it got affected to the section 1 itself. Okay, so what I will do, I'll delete complete this wing model, and I will add default wing, and for this default wing I'll change the sweep angle 30 to 0 degree. Okay, so yes, and you can twist your model. So here you can do other changes. Root cluster and tip cluster you can increase, and even you can increase the span. Currently just I'm doing a rough model. Okay, tomorrow I will go as per the requirement. Okay, so this is our, so yeah. So let me do some other changes also. Root quad, tip quad, little bit will increase. So aerofoil default aerofoil we have. So even I will change the aerofoil 2%. I'll keep the quad, and location of quad I'll maintain 40% from leading edge. Yes, so it's a unsymmetrical aerofoil, which means I have added unsymmetrical aerofoil for this wing model, and I will share this. So this is our one rough model. So for this rough model, even you can even do other changes, or you can just let me delete this. Okay, so for this sweep wing, okay, now currently the wing what we have, that is a swept wing. Okay, so for this swept wing or sweep wing, we will do changes by splitting its component. So currently we have completely one section, one wing section. Okay, so I'll split this into four section. One, two, three. Okay, and here is the fourth. So I will come to first section now. Okay, first section sweep angle I will maintain just 25-degree. Sorry, 25. Enter. Okay. And second section I'll jump now. I'll maintain 40-degree, and now I'll jump to third section. I maintain sweep angle for this third section, that is 45-degree, and the last section. Okay, this one what I will do, I will convert this that horizontal wing shape into diagonal with 90-degree. Okay, and again I will come to first section. Yeah. So in this first section, I'll change the span. Okay. And I'll increase a little bit chord. And yes, this much is okay. Now I'll come to aerofoil. I'll change aerofoil. I'll add 6 series aerofoil. And I will increase thickness to chord ratio. Okay. So now I will shade this model. So this is our blended wing. Okay. Now material what we have, the default material we have. Okay, that is default material. So we can change default material into the required material, blue plastic or aluminum or gold, silver. I'll select rubber based yellow, no, black rubber. Okay, so model will look like this. Okay, put on screen and write ISO. So this is all about today's topic, the rough model whatever we have done. Okay, so tomorrow we'll do as per the given parameters. So this is how you can easily design your any kind of wing by adding or by designing aerofoils. Okay, any kind of aerofoils you can add and you can design your required wing. So this is all about today's topic. We'll continue tomorrow. Thank you to all.
Thank you, sir. Thank you.
Okay, thank you.